Pause this video for a moment to read the full problem statement. I have here on another slide a visual description of what's happening in this example. So we're told, first of all, that our sample space has the following elements. So I've placed them here. Those are the numbers 7 through 18. Next, we're told that F is the event that contains these values 8, 9, 10, 11, 12. We're also told that G is the event that contains the values 12, 13, 14, 15. You can already see I've started to overlap these two events because technically 12 should belong here in both F and G, the way that we were given those two sets. So when we return back to this question, list the outcomes in F or G, what we're doing is we're listing all of these values that are in both F here, G here. So in other words, they're in this blue space, this green space, or even in this overlap space. Those are all of the outcomes in F or G. Next, we're asked to find the probability of F or G by counting the number of outcomes in F or G. So let's return back to our slides. For this one, really what we're looking for here is the number of outcomes in F or G, and we're going to divide that by the total number of outcomes in the sample space, S. So let's count them up. We have here 1, 2, 3, 4, 5, 6, 7, 8 outcomes in F or G, 9, 10, 11, 12 total outcomes in the sample space. So that's 8 over 12, or if we divide and get a decimal answer rounded to 3 decimal places, that's 0.667. In the last part of this example, we're asked to determine the probability of F or G again, but this time using the general addition rule. So we should come up with the same answer, 0.667, but let's see how that plays out. So here, the general addition rule states if we want to find the probability of F or G, we find the probability of F, we add to that the probability of G, and then we subtract the probability of F and G. Now, F and G is different than F or G because it's this overlapping space here. Notice that there's only one possible outcome in that space, F and G. So if we find the probability of F, we'll count up the total number of events that occur with F. That's 1, 2, 3, 4, 5. Notice I'm counting there the 12. If I find the probability of G, I have to count up all these events in G. So that's 1, 2, 3, 4. But notice I've counted 12 again, okay, whenever I take that count. So now I have to subtract the probability of F and G. So that's one element that's in F and G out of the total 12 elements altogether in the sample space. So each of those was out of 12, or in other words, 8/12 again. So in general, what this general addition rule does is it takes into account any overlapping space that we may have duplicated when we find just the probability of F and we add to it the probability of G. Notice we have to subtract one case of duplicating whatever is in the intersection of these two sets. Back to the MyMathLab problem, all you're asked to do is round those values to decimals, 3 decimal places as needed. But again, we come up with the same answer that we had when we just counted the number of outcomes in F or G